Should we get started? Okay. Normally, our Rocky Mountain Ham University Director of Education and Chancellor, Willem, would introduce and tell us all about this. But Willem's work ran long, and he is still in traffic, and he said the roads are kind of bad down where he is. So he said, introduce yourself. So I guess everybody probably knows me. I'm Doug, K2AD. Yeah, it says it right here. And we also we're coming to you live from the CTM studios in Firestone, Colorado, the home of Mark, N7CTM, and he's in the background. And we also have Dave, WO1JHK, who are our technical directors for this session. And I believe you should be seeing the slides in a portion of your window. I have a little different windows, but they're seeing what's up there. And so am I seeing on that monitor everything that they would see?
Right now.
Okay, so when Dave is ready, we'll switch over. But so this is a session of Rocky Mountain Ham University. Normally the university sessions are on a Saturday from 8 till noon and down both on Zoom and at the Cherry Creek schools down in Cherry Creek, Colorado. And I think the next session will be in a couple of weeks, and we had to move the schedule around a little bit, and instead of doing 3D printing, we're moving up, I think, IPv4 and IPv6, and we're going to move the 3D printing 2 months in the future because of some family commitments of the speaker. So take a look for that. But we do these tech talks, which are shorter sessions, hopefully of interest to people. And tonight's is going to be on some repeater pieces. So what we're going to talk about is one of our partner groups, the Colorado Repeater Association, has started an initiative to upgrade our repeaters. We've been using multiple platforms, multiple styles. Everyone is a little different. And we've had an opportunity to pick up this, I've got one here on the table, this Motorola MTR 2000. There's the front cover. And we're going to talk a little bit about the controllers that we use and how to interface to this. And really, what's the next level down? Peel the onion back one more layer. What are the signals? What are the voltages, the fidelity, frequency of these lines? And what do we have to do to make these repeaters work? So, Dave, if we can throw the slides up. So I'm still seeing all the people. There we go. So welcome to Repeater 102 is what we called it. I started to wonder maybe we should have called it Repeater 201 because I did Repeater 102 back in January of 2019. I can't believe it was that long ago. So we're going to use this, and I'm going to get my fancy pointer. We're going to use this deck, and I modified it a little bit to change to this. So back then I used a Jeopardy theme. So the categories for today are repeater basics, interfaces, the digital transition, call signs that begin with the letter K, system applications, and a potpourri. So since Mark and Dave, you're the technical directors, where do you want to go on the board?
Repeater basics for 400, Doug.
Okay, very good. We'll do repeater basics for 400. So I'm going to kind of go quickly through this. So if you miss something or want a little more, just unmute, interrupt, and we'll go. But one of the first things that we have to do to get this thing to talk to this thing is to get all of our interfaces correct. That can often be difficult when we have a variety of handheld radios, mobile radios, running around with various mic gains and deviations. So we're going to talk about that a little bit. We're going to talk a little bit about flat audio, emphasized audio, how to make your repeater work, and some of your test equipment. So no presentation is complete without a slide that you can't possibly understand because it has too many mathematical symbols, and it's from the Hong Kong Polytechnic University. But if you're really wanting to get into FM and you want to do the math, this is a great slide. You can find it on the website here. There is a difference in deviation in mic gain. If we're talking an AM or a single sideband transmitter, mic gain very much sets the amplitude of the modulation. That's what AM, amplitude modulation, stands for. But when we get into FM, it's a matter of how much are we deviating the signal in frequency, and then do we have enough mic gain going into the radio to bring it up to where we're going. If you're, where we can hear. So you can look at, there was a nice article that I stole from k0bg.com. It's credited up here. If you want to look at that, you can. But basically, when we get into FM, we're talking about deviation. So we're modulating the frequency of the carrier up and down, and that's kind of neat the way I can look at myself, and my hands are opposite to this. So that's kind of cool. I feel a little bit like David Letterman here getting hypnotized. But so we're moving our carrier up and down in frequency by a particular deviation, and then we modulate our audio on that. In the modern radios, well, in ancient radios back in the 70s, 80s, 90s, we always had a deviation control, a potentiometer, and we had a mic gain potentiometer, and you could actually set these. With today's radios, they're kind of difficult to, sometimes especially in the Chinese radios, they hide those things from you, and you get what you get. So just keep in mind that we're trying to get a consistent signal out of our receiver such that we can pass it into our controller and pass it back to our transmitter so somebody else can hear you. I threw this in here from the previous deck. I just left it in. We're going to be talking specifically today about analog FM, what we call wideband, the emission designator 16K0F3E. What that means is we're occupying a 16 kilohertz of bandwidth in the radio spectrum, and we will use 5 kilohertz of deviation to fill that. That's plus and minus 5. And then with the sideband energy, it fits within a 16. You'll probably notice that it takes 16 kilohertz, but what are most of our repeater frequencies on 2 meters separated by? 15 kilohertz. So I'm putting a 16 kilohertz signal into a 15 kilohertz wide space. It's kind of like parking a Chevy Suburban in downtown Boulder. It just doesn't fit. So we have to play a lot of games with frequency coordination, and Tracy, our frequency coordinator, is actually on here on the call today. So when you are asking for a repeater coordination and Tracy tells you, I don't have anything that fits, we've had to really play with spacing and play some games to get everything to fit in the 2 meter band, and that's probably why. Some of the digital modes are listed down here, and they're just for a reference on here. Going to talk really briefly about repeater performance and how we get into some of these. What audio is coming out of your repeater receiver? Some people call it speaker audio, some people call it line audio, some people will refer to discriminator audio. But there's potentially 3 signals or 3 frequency ranges that mean something to us. At the very bottom, we have our CTCSS here, and that's the digital tone signaling, and I'm going to have to mute my cell phone here. I apologize. I should have told all of you to mute your phones in the room, and here I didn't. So we have our subaudible tone, sometimes called PL, private line. Harris calls it channel guard. Quiet channel, I think, is Kenwood's. But it's continuous tone-coded signaling system. It's a subaudible tone, between 67 and 250 hertz. And that needs to be there if your repeater is using that for signaling, to say, hey, I'm here or I'm not here. Then just above it, we have our voice band, and that's what we're all listening to today. One that's often forgotten is this 3,000 and above, and that's intended to be white noise up there. And that's where your squelch circuit works, and if you're doing receiver voting, that's where we see, hey, is there a signal there, and how good is it? Is it more quieting, better signal to the noise than another receiver in the network? We'll also today talk a little bit about emphasized and de-emphasized audio. The analog FM receiver, or the transmitter actually emphasizes your audio 6 dB per octave. And that's a standard. All radios do that. So what they're doing is 6 dB in voltage is double. So we're actually sending more, as the frequency goes up, we're sending more level, more audio through. Why do they do that? Because 50 years ago, somebody said, hey, or maybe it was even 60 years ago, there's a lot more intelligence in these higher frequencies, so we're going to send more of that through to improve the quality of the circuit. Then the receiver on the other end has to apply a mirror image de-emphasis filter. Otherwise, you're going to all sound like Donald Duck or Pinocchio. So there's emphasized, there's de-emphasized, and it's important to know what you've got coming out of your radio so that you can put it into this controller here, which is off the screen. There we go. So there's those. Okay, so I talked a little bit about, I think everybody on the call knows the difference in carrier squelch, just normal squelch. Is there a signal there or is there not? And if there's excessive noise, it can open the squelch circuit. If there's intermodulation, it'll open the squelch circuit and it passes. If we use CTCSS, analog tone for signaling, or DTCSS, digital tone coded squelch signaling system, we can keep some of that noise out. Most people these days use CTCSS. So DTCSS, or DPL as it's quite often called, you'll see there, it's a 3-digit, I guess it's a hex code. It's a 3-digit code that you'll use. A lot of people use 073 as a common code. Others will use 025 as very common. But so we've got these tones. This little graphic here, so we've got our frequency modulation here on the left in the green, and that is just a carrier. Then we have our voice, and then what comes out of the transmitter frequency is frequency modulation. We're changing based upon the frequency of your voice. When we add the CTCSS in here with what they call the privacy tone, you notice these two waveforms are different because you have both the analog passband and you have that CTCSS riding underneath it, and hopefully you don't hear both. I stole these slides off the internet from ZL2 Papa Delta, and they're a nice way of showing a CTCSS encoder, which, oops, wrong button. There we go. CTCSS encoder is right in the middle here. This is taking the signal, mixing it with the voice, the microphone amplifier, the mic audio, sending it into the FM transmitter. This assumes that the input to your FM radio is able to accept 67 hertz through 3,000 hertz. Some transmitters that are shown down on the bottom here, there's actually a separate input to your transmitter, your exciter in the repeater here, for the CTCSS tone or data signaling than the voice signaling. That's very important when you get into your controller. Can your controller, does it have them split or does it have them combined? And picking your proper thing, your proper mode here on the left. On the right, he's showing a simple block diagram of how CTCSS decode works, where we're coming in, it's coming through the amplifier RF amp to the mixer to the detector, the FM demodulator. And then the signal is actually split. It's sent through a high-pass filter to filter the analog CTCS tone away and just let your voice energy go through on the top, up, there we go, up on this top line. And then on the bottom line, we actually have a low-pass filter that says, if you're above 260 hertz, we're going to squish it away, strip it off, and we then send that less than 250 hertz into the decoder that does a level crossing or a predictive algorithm to look for peaks to figure out what tone are we hearing. When it does hear the tone, this little circuit says, hey, unmute the audio and pass it to the speaker. And hence you only hear signals that have your tone. So what we're going to talk about here today is, does your repeater, does your receiver pass that tone that's needed to unsquelch it through to the controller and into the transmitter? If it does, is it a clean signal such that somebody can actually demodulate it? Should I instead inject my own and make it clean? But what if we're on a split system like the Colorado connection where you're transmitting 88.5 in, but we're sending out 123.0? You can't have two, especially if you're looking at zero crossing detectors. That thing is going to get very confused. So something we're going to have to look at. This next section, and how am I doing on time? Okay. I'm going to go very quickly through, and then, so just some points, some things to think about. More power is not better. You don't have to have a 100-watt transmitter on your repeater if your receiver can't hear the signals that are coming back to you. If you're desensitizing your own receiver with your transmitter, run less power, you'll have a better repeater. As I said here, receiver performance is king. No one likes an alligator. Build an elephant with big ears. Elephants can hear everything. I'm going to leave these slides in, but I'm not going to go through them. If you're having questions about, do I have enough filtering in my duplexer between my transmitter and receiver, there's some pointers here and tests, or give me a call and I'll help you through this. Same thing with cavities, noise floors. We have a bunch of sites that have a lot of noise just coming in, natural noise. And when I put a dummy load on the receiver, I can hear a signal. Then when I put the antenna on, I've got to raise my receiver energy by 10 to 15 dB. That's a very bad repeater site. And you'll need some test and measurement equipment. All of these levels, CTCSS tones, audio levels, transmit levels, you need good test equipment to debug it. Bob Whitty at Rocky Mountain University just this last session, last month, or this month, earlier this month, gave another talk on test equipment. And if you have not attended any of Bob's sessions, you need to. They're great. He is a wonderful speaker, and everybody will learn something from Bob. But he went through his first law of electronic measurement, and I love this. With electricity, most of the time we cannot observe what is going on without measuring instruments. His second law, when we can, it's usually a bad thing. And boy, do I know this. I've seen this myself. So, and Bob went into spectrum analyzers, oscilloscopes, and network analyzers in the last one. I guess he even did voltmeters. But if you didn't see it, look it up on RMHAM.org at the university. It's a great talk. So we're going to talk a little bit about interfaces and then I'll get to take a breath. So repeater interfaces for 800. I guess this is double jeopardy because we're going in bigger increments. So we're going to talk a little bit about analog and digital controllers. One of the, this isn't the basic, but this is the workhorse. This is the controller that won the West. This is the SCOM. This is their 7330. So essentially their 4th generation of controller. It's got a single printed wire board. I'm just going to hold still, Mark. Oh, there we go. SCOM controller. This is 3 ports in. I've got a little special dongle that we'll talk about, but 3 repeater ports on the back, LEDs on the front. This in the analog world, in my opinion, was the king of controllers. What you do is you hook your receiver up, you hook your transmitter up, and you configure Dave and Bob at SCOM, and the same Dave that's our technical director behind here. You set all these little jumpers to tell it whether you've got emphasized or de-emphasized audio, whether you need high gain, low gain, depending on how much voltage is coming in, whether you want the audio delay boards so that we've all heard the, what do they call it, chicken burst, where when your radio unkeys, you hear that. Well, if you are using CTCSS, you can turn that tone and mute before it goes down, or if you're using carrier, if we just delay the audio by, what did we delay, Dave, to get rid of the reverse, the chicken burst, like 40 milliseconds, 60 milliseconds? Yeah, just a small delay, and he's got a really nice delay circuit with a potentiometer that you can adjust how much delay you want. And when they sees that line go down and that goes away, we're delayed by 60 milliseconds, so we turn off the controller and you don't hear that noise. Really good controller, but it's analog. If you want to link using this controller, you've got to use one of these other ports to put it to another analog radio to go across the state. Wonderful radio, wonderful controller, but it's not in the digital domain.
What about just
So
linking
what we
another
did is
repeater?
we went to this RTCM. Here's one actual size, so you can see. And there's one on the screen here, but it's not very big. There we go. So just connectors on the front, minimal LEDs, nowhere near as nice as the SCOM. But this controller takes the audio in, the transmitter out. We hook a IP line to it, Ethernet for a digital backhaul, and then put not a simple server, but it could be on a Raspberry Pi, but it might very well be a 1-rack unit PC to do all of the technical smarts. Let me look at my slide here. Yep, it's simple interface. It's a little complicated to program. This unit will do receiver voting. If you use the URI, so that's the RTCM that's right up here. If you use this URIX, this has even less smarts than this thing. You definitely have to put the Raspberry Pi to do all of the processing and materials. But if you have this RTCM, it does receiver voting. How does it do this receiver voting? Remember, we talked about that top line of noise, signal to noise ratio. The controller is looking for that noise, and it says, do I see white noise there, or do I see quiet? If I see quiet, I have a full quieting signal, like people talk about on the radio, on the repeater. If the signal isn't full quieting, there's noise, crackle, pop, we'll detect that up in that range because you don't have voice energy up there. If we try to look at that between 300 hertz and 3000 hertz, we've got our voice going through that, and that's going to confuse the squelch circuit, the signal to noise detector, So this unit has a squelch and a diode detector to measure noise, and that allows us to do voting. Okay, and looking at my time. So I only threw in a very brief number of things that's pretty much described by the bottom. Why are you talking about digital when tonight we're talking about analog? Well, we're really not talking about digital. I just threw this in here to say you may see FDMA, TDMA, CDMA out there. We are talking analog tonight, which is a frequency division multiple access kind of system. I put a repeater on a different frequency for everybody. I don't share. When we get into turbo, or I guess that's, or P25, Tracy's on here and he's a P25 guy. Those can be TDMA, which means we're actually sharing one repeater, the time slots back and forth between two users. We don't have any CDMA systems, but you may see this out there, but things like D-Star, Fusion, NXDN, they're FDMA. That's a single data stream in a frequency carrier, whereas analog FM is an analog signal, single in a carrier. So, but that's basically that. Now we're going to take a breath and go to call signs that begin with the letter K. So I didn't have enough topics, so I threw in this category. So I guess the answer is who is K2AD, but I just wanted to take a minute to kind of acknowledge who's on here and what we're doing on here, and take a swig of water. I originally started this because I had a number of requests by the Colorado Connection guys to give a little more information about how our repeaters work and what they do. And as most of you know, I'm involved with Rocky Mountain Ham. I volunteer with the Longmont Club, Longmont ARC, the Northern Colorado Club, CRA, I work with them a bit, ARA, the Aurora group. We're all starting to converge on this new platform that's on the table here. And I kind of want to get some energy, some interest in, let's keep driving our platforms to a common place. Let's use a common implementation. It's going to be a lot easier for all of us. So we had 45 people signed up, and now I know the ARA, CRA, Calcon, Fun Machines, Longmont, Northern Colorado, Rocky Mountain Ham. I saw some guys in from Wyoming, Estes Valley maybe on here. So we've got a lot of guys on the call. I also want to acknowledge our technical directors in the back of the room there, Dave and Mark. And we couldn't do this without them. So, I'm going to take a breath. I know I went quickly through some of that stuff, but we're now going to get to more of the Q&A part. Does anybody have any questions, or is this making any sense? Somebody tell me while I take a breath here. We can unmute the lines. And is this all good so far? I'm going to take silence as positive, because if it's not making sense, I'm going to go get my can of liquid death here, and I don't want to go into that one. So that's just sparkling water, by the way.
On chat, N2XGL said it's all good so far.
Okay. Well, thank you, XGL. And you guys can comment in on chat, but feel free to open the microphone and chat. So I'm going to do a little bit of ranting and free-floating hostilities, as George Carlin used to say, about crap radios. And are they seeing this on the air? Because I'm seeing only me, Dave. Okay. So let's talk about crap radios. There's a lot of weak signals running around on our repeaters, and a majority of them have a piece of crap in their hand. I looked and saw that you can get some of these Baofangs for $32.99, and this company that sells them is called Bang Good. Well, I'm not sure that that Bang was very good. So, you know, consider you get what you pay for. The audio quality is terrible on some of these units. It's half the level of other units. How do you equalize and how do you balance your repeater when the audio levels are all over the map? So the way we do that is receiver voting. When we're dealing with a really low power radio on an antenna that's non-existent, we do a lot of receiver voting, and we're going to get fairly deep into this. In the case on the lower left here, we've got one of the dashboards from Qualcomm that shows our 4 current receive sites. We have 2 of them, 2 more, but they're currently offline for another reason. But so the receiver voting requires one of these RTCMs. It's the only module that we have that will do receiver voting that does this all-star interface and the radio over IP on the backside for the link. There are analog receiver voter blocks that are full 19-inch rack panels. They're like 5 inches high, and there's a card for every receiver, but that's how we did it years ago. But the receiver voting, the signals come in every 20 milliseconds. We look and see, oops, wrong button. We look and see down here who's the strongest. And this one I recorded earlier today, and at this instant, our Conifer Mountain receiver was the strongest, and the others were pretty strong. But you'll see these things bouncing back and forth every 20 milliseconds, and it really does work. So, as the most interesting man in the world says, receiver voting works. Stay sensitive, my friends. But, excuse me, these voting receivers, this is good seltzer water. I got the hiccups though. Needs a GPS reference. We have to be able to make voter receiving work, we've got to take all of our data streams and line them up and then look for which one is the strongest. Well, how do we line them up? We use a GPS receiver. There's some samples down here of the ones on the left are the ones we're trying to use. And the one on the right is one that we thought we were going to use, but then we realized it's missing something. But these receivers take a GPS signal in, and it puts out a very precise 1 pulse per second signal that the controller uses, and it says, okay, now I know how to line these up, and I can line all these incoming packets up and pick the strongest one. And I gave Mark and Dave a clue. Why is this guy over on the lower right here a bad receiver? It's missing PP1S, and I got all excited because this is a nice small board that has 4 mounting holes that I can mount in a box, like this one. This is actually one that's mounted, that's like on the left here. But this doesn't have a lot of mounting holes, and it's really a pain in the butt to put in a metal box. And then I realized there's no PPS, PP1S or 1 PPS, whatever you want to call it. So something we're working on. So,
what is that, Doug? What's that PP1S?
okay, we're going to have to turn the volume up. I heard somebody. Dave's going to fix it. This is kind of our trial.
I'll get a little
run
closer.
Have you done one here from Mark Studios before? So this is the inaugural. Okay, I think that was maybe Steve.
Yeah, I was just asking what the PP1S or 1 PPS is.
Okay, so coming out of this GPS receiver are what's required for this voting receiver or controller are 3 serial data messages that either come out at 4800 baud serial or 9600 baud serial. And those messages tell us the time of date, the satellites, and all these things. The PPS, or 1 pulse per second, is literally a pulse that comes out every second, and that allows us to get the time reference so that we know how to line all these back up. So when the PPS signal comes out, I line up all my thumbs as opposed to having these things out of phase, because I don't know how many, if I'm receiver voting every 20 milliseconds, if I have a IP line that has 100 milliseconds of latency, how do I vote that? Because the strongest signal may have arrived at the repeater controller 100 milliseconds after the other signal. So what we do is we delay all of the signals, use that PPS to say, now is the start of the packet. And so that's what that is and required. Does that make sense?
Yep, thank you.
Okay. It's quite an important thing. Now, the other thing we've done is, pictured here is a Neo, is that a 6 or an 8? But we use these U-blocks, Neo 6s, Neo 8s. We've had some trouble with, they don't all talk to each other properly. And that's a little bit of a problem that, you know, I'd like to have identical GPS receivers at every site, but I might not. So we need to work on that, and that's a project we're going to be doing going forward. So, do you have a question, Dave, or?
There was a question on chat. Kristen asked, do you run any AGC on the repeat side on any of the systems?
That is a great question. No, but I'd like to get to the point that we can, such that when people are transmitting in with very low audio, that we naturally try to raise that up. And I think we can do that in software. And Dave, isn't that being considered for future controllers? But that's a great question, Tristan. The older controllers like this SCOM, we didn't do that. We required you to have enough level, but hopefully we can overcome that. And the reason I'm kind of going back to Dave is we're going to talk a little bit about where we're going in the future. So I've showed you this RTCM. This is the module that Colorado Connection uses. The Fun Machines use this. Who else? ARA has a number of these. Northern Colorado Amateur Radio Club, Longmont Amateur Radio Club. We all have these RTCM modules. There we go. And this one, as you can see, has the GPS is set for 9600 baud RS-232, because that's another problem, that some of these GPS modules, wherever it is, they put out TTL signaling unless you put an RS-232 converter on, which we're going to be doing on the new receivers we're making. So a lot of clubs use this, but they're kind of pricey for what you get. And at one point they weren't being made anymore, and then they were, and the guy that made it was going through a separation from his wife, and they weren't available until they settled, I guess, finalized, and now they're available again. But what we want to do is make our own module this is public open source stuff, and we want to do our own that actually fits into this repeater here. So, this is one of the old slides. You should be able to take any repeater and plug it into any controller, right? Well, not really. Mark is in the background going, oh no, because he and I have spent days looking at things that were just futile. And okay, 740. And potentially you can make anything work into anything. But we used to have a phrase when I worked at Ericsson Lynchburg in the mobile radio division. We used to say, anybody can build just one. Question is, can you build 1,000 and have them come off the factory assembly line, production line, and work? So we talked a little bit, we didn't talk about DC voltage and ground, but you guys all know you need that. Receiver audio, you got to figure out what does your receiver put out? Is it emphasized or de-emphasized audio? Is it squelched or unsquelched? Do you get a signal that says there's a signal here on my carrier, my COR or carrier activity sensor or whatever? And is there a CTCSS or a DTCSS signal? Same thing on the transmitter. We've got to put the right kind of audio in. We've got to put the push-to-talk signal. And we've got to decide, is the controller putting the transmitted tone or is the repeater actually going to inject it? So, and I didn't put DTCSS on here, but I should have. And the other piece is these COR lines, these push-to-talk lines, the CTCSS encode, decode lines. Are they what we call active high? So when they're active, they go from 0 volts to 5 volts or 12 volts? Or are they active low where they're normally sitting high and they drop to 0 volts when they're active? If you've got an SCOM controller, like Dave designed here, he gave you little jumpers that you can tell it what you got, and it pretty much interfaces to everything. I wish it had receiver voting and an IP port, and if so, I wouldn't be looking at other controllers. But Dave is going to work with us, and we're actually designing our own, and he's participating in that, and then we'll make it available as an SCOM product to others so that others can have it. So with the 7330, you just hook it up, program your radio, you're pretty much on the air. You've got a little bit of audio level adjustments, but Dave, isn't it that easy? Because you've done the engineering. Yep, he's giving me the thumbs up in the background. When you're dealing with an SCOM product, it's just that easy. But what if you're not? This is a slide, and I apologize for the busyness, but this is a Kenwood repeater that you can see down here on the bottom. That's the Kenwood TKR 750, 850, VHF or UHF. And this is hooked up to an RTCM, which you can't see the picture of it, but there's the actual outline of the schematic that tells us where all the jumpers and things are. And this is a documentation page that Mark Skelton here made up. And we kind of said, well, gee, we should just be able to hook this up like we did in SCOM. We thought this was going to take us, what, an hour, Mark? How many hours, days did it take us? So it should be easy. Yeah, you just hook your receiver audio up. Mark apparently spoke before that. How many hours was it, Mark? Yeah. Yeah. So, a long story short, our signaling lines, where we can program the Kenwood to be active high or active low, they weren't going all the way, and so we had to build some buffers because there are no buffers in this. In the SCOM, there are buffers. There's opto-isolator buffers, lots of buffers so that things don't blow up and they move from high to low. This is a piece of crap. So, took us a while, but we eventually figured it out, and we have a number of these. You just have to build Mark's little circuit that's right in there. He shows the transistor and the things on the line. Set your dip switches inside this. Set some software in the controller, in the main controller, and you go. Then we got the Motorola MTR 2000. That's what's right here on the table. And that's where we're going to be going, and I'll tell a little story about that actually is a story that does apply to this. This is not a squirrel. So we said, okay, well, let's run the RTCM into this. Well, we took the receiver level, a receiver discriminator out of this, and in the Motorola software, we programmed it to be emphasized audio, which is what the RTCM wants, unsquelched, so there's always signal there, regardless of the PL or the squelch conditions, and ran it into the controller and worked pretty well. We did have to set there, oops, wrong button again. There's a little jumper down here that you have to set for high gain, low gain, just like the SCOM has. And it worked. Well, kind of. But then when we put the transmitter out of this module into the repeater, it was dirty. Dirty picture on the oscilloscope. Spikes of noise everywhere, and it sounded like I was dealing with a Rice Krispies treat. So we did a little more investigation, and we found out that for whatever reason, the op amp in the RTCM cannot drive the Motorola. So we said, okay, don't use the mic input, run it in through the audio line card, which is the 1970s and 80s way of sending 4-wire audio, 2 wires for transmit, 2 wires receive. That's the way they used to hook in an old dispatch center. And through telephone lines from the police station could make a radio call and hear the radio calls from the mountain. Well, you can do that, but there's a little bit, just the tiniest bit. We worked really hard to get it clean, but there's a little bit of audio roll-off. And for that reason, I don't like to use that as my first line of defense, but that's what we had to do to make it work with this repeater. And I'm going to peek ahead. Okay. So it's a reasonable solution. Thankfully, we have the audio line cards in all of these repeaters. It is an option. It's one of the cards that fits right in the front here. Oh, okay. I thought one was missing. No, there's one in there. It can work with the RTCM. And part of the reason I'm spending so much time on this is Colorado Connection was lucky enough. So far, we've had 8 of these repeaters donated, and I believe we have another 4 to 6 on the way as part of the donation. There is a lot of benefit to being a 501c3, and we were able to get those donated, and we're doing a bit of a fund drive to get the other pieces that we need. And our goal is to deploy at least a dozen of these on our biggest repeater sites and all across the state. And they'll all be identical and the same. So we're going to come back to this one. Then we said, well, there's also this new Motorola SLR 5700s right down here. It's a real nice little repeater. We call it a pizza box. It's 1 rack unit tall, 1.75 inches thick, 19 inches wide. It's about 12, 13 inches deep. Got a 50-watt transmitter in it. It's continuous duty, battery input. Even has a battery charger, so you can hang a battery off of it. Power supply built in. Seemed like a great little radio. Great repeater. Just like interfacing to the MTR 2000. This should be easy, right? Well, it's got a DB25 plug on the back. How much easier can it be to interface than that? Well, we found out that the CTCSS signal, that when we tell the repeater to generate it, it doesn't properly generate it when we tell it to generate it. That was a problem. The other problem was our receiver discriminator didn't have any energy above 3,000 hertz. This RTCM module, as I mentioned, needs a squelch circuit and a detector circuit above 3,000 hertz. It just won't work. It's a showstopper, and that's why I made this little, it's not totally a joke. You need a large rubber mallet to beat this thing into submission, and then it still doesn't do it. Great repeater, but we don't have a solution yet. Likewise, and I don't think I have a slide on this, the big brother to this is the MTR 3000. And that's a digital repeater. It's digital and analog. It'll run DMR, and that's what Rocky Mountain Ham uses as one of our DMR platforms. We do use this SLR 5700 right here on our DMR repeaters, and it works great for that. So if we have a 50-watt repeater site, we'll use one of these repeaters. If we're running the 100-watt site, we'll use the MTR 3000. It also drops like a rock at 3,000 hertz and will not work with the MTR or with the RTCM. So kind of a pain. And okay, so what our plan was for the Colorado connection. What, Dave? Oh, okay. What we were going to do for Qualcomm going forward was we wanted to use the MTR 3000. We can't. So we're going to use the MTR 2000. Some have asked me, isn't this thing 20 years old? Yeah, but it's solid. A majority of the ones that we were donated spent most of their life as receive-only units. The transmitters have barely been used. The receiver discriminator is good. We can interface to this. It doesn't have the MTR 3000 problems that we talked about. It's only 5¼ inches thick. And inside of that is the power supply. And there's the power supply on the lower right. The power amplifier, the receiver modules are in this middle section. Let's see if I do. Yep, so our receiver and transmitters are in the middle, the controller, the repeater, well, the hardware controller, the piece that loads the synthesizers and does all the magic in the repeaters in here. And there's the power supply and the power amp. Whereas our old repeaters were at least 16 inches, if not greater, thick. And these days at repeater sites, we pay by the floor, the footprint on the floor, the footprint on the tower, and the price is going up and up and up. So, so with that, what are we going to do for a controller? And that's really part of the reason for this session, is the RTCM will work. But what we want to do is do a new board layout, not relayout, a fresh board layout that actually places this repeater. Mark, you may have to move a little bit. I'm going to move on you. He told me to keep my ass in the chair and not move around. And if you can, actually, all I have to do is, if you can zoom in on the cage, the card cage here. Can you zoom in on this? It's not zooming. Oh, there we go. Okay, you can't quite see the line card here. It's the Motorola line card is behind these cables. So there's the line card, and right below this, and this is just it has a 96-pin Euro connector and a bunch of components on it. And right below this are some empty slots, 2 more, that our goal is to put all of there's the receiver cable, there's the transmitter cable, to fit this entire controller in this area. So that we have no more on bare cards. We don't have to do a box, mechanicals. We'll just fit them into cards that fit in this thing. My goal is also to pick up, and if you get this wonderful book from Motorola that's available on Repeater Builder, there's a chart in the back that tells us what all 96 pins on each connector does back here. And there's very useful things like receiver audio, PL, detect, CTCSS, transmit audio, push to talk. Then there's things like power amplifier failure, VSWR alarms, the repeater is detecting a high VSWR. Since this has an AC and a DC input, if the AC power fails and it switches to DC, it'll throw an alarm line. We want to bring all those and into the controller so that we can remotely read these things and see, is the repeater telling us our power amplifier has failed? That's what happened at the Akron repeater. And I believe also, well, I think Fort Collins has a similar, but I think a fuse blew on Fort Collins, but in Akron, I think the power amplifier blew up. Wouldn't it be nice to have an alarm? So we started a team, and I think Will is on the line here, N0XGA, kind of anchored in the Colorado connection, but we also had Dave from CRA and Jeff from the Fun Machines. And we've started doing what we were calling Voter 2. And we've laid out some boards. They're big boards, but they're just prototype right now. But our goal is to continue that and actually get it down into the form factor that'll fit in these stations. And so I've kind of, without Will's permission, he's the project lead on that, renamed it Voter 2K because it fits in the MTR 2K, MTR 2000. So it'll be Voter 2000. That's a project we're working on. Other groups are obviously involved. ARA has expressed interest in the Aurora repeaters, and will probably eventually migrate to the same boards and help us fund the development because we're funding this ourselves, and that's part of what the fundraiser drive that Qualcomm has going right now. So shameless plug for send money. We're going to do some good things with it. So Voter 2K, and okay. And how are we on time? 8 o'clock. Okay, perfect. So we talked about the MTR 3000 and some of the problems it has. This module needs to have the squelch energy, the signal to noise diode detector to do voting. That doesn't exist on the MTR 3000. I think it's even on the MTR 2000 though, but there is a pin in here that if I could find it in this 50-page manual, marked RSSI, Receive Signal Strength Indicator. We're still learning how to deal with those. What is that pin really doing? But we may be able to get around not having above 3,000 hertz of energy on the receiver. If we do, that'll probably be a Voter 3K because it'll be specifically designed to drop into an MTR 3000. And then after that, Dave has been working as part of his SCOM, as one of the principals at SCOM. He's working on a controller that's very similar to this, but I kind of described it as it'll have a lot more bells and whistles and features, and it'll be the SCOM quality level product that I hope ours is as good, but they put a lot of work into their product, and I'll be happy if we come halfway to SCOM reliability. I'll be very happy. But I don't know how many thousand SCOM controllers are out there, but I probably touched at least 50 of them. I've only had one fail, and that was a Zener diode, and it was easily repaired. They just don't fail. So we will probably have a bigger version of this that these will work with when Dave finishes his design. So it's a very collaborative thing, and so this is kind of where we're going. We're going to start to deploy these new repeaters. Unfortunately, got to take the SCOM off the table for now. Dave's giving me the thumbs down on the back, but because it doesn't have a digital interface. But the RTCM will be initial. It'll be an easy upgrade to the Voter 2K when we finish. A lot of clubs are participating in this effort, and if you do participate, you obviously, you get to buy these things at cost. You know, you're part of the development team. But this is the direction we're going. It's going to be a lot easier. Right now, for the RTCM, I have this little board here. Where am I? That's just, I found this thing on eBay, and it was intended to be an interface board for like a Zetron panel or something. But it has the 96-pin connector on the back. Here we are. And has the 96-pin. And it's basically a breakout board. It has all 96 holes here, and I just wire onto this. There you go. This was actually my first prototype. Geez, 2021, November. So, and this just plugs right into the back of the repeater where there's a matching plug that there, and a cable comes around to the RTCM. Is it here? Plugs in the front, and if this was actually hooked up, lights would come on, repeater would work, hook an Ethernet cable to the back, hook a GPS to this DB15 if you want voting, and go. And we're going to be building a lot of these, like in the order of 24. If you're new to the call here and you're not part of the fun, you want to get in on, you want a piece of the action, let me know and we'll order some more. We're just offering these at cost to recover our costs. So,
I had a question there. Internal reference. Give us a brief push on that.
That's a great question, Mark. So the external precision 10 megahertz reference input that he's talking about right here matches up with this unit. Oh, let me just say it. We have hopes that with a little bit of work and a little bit of interface, that this unit will simulcast on analog FM. What is simulcast? We all know, we've all heard doubling on the air. If you get on the Aries net or the CERN net or any net, people are always doubling. When you get a double, you can't have two people transmitting at the same time without hearing a terrible squeal, or it sounds like you're doing terrible things to your cat with a fork. It's just bad. But if you precisely lock this transmitter in this repeater, and you lock your clock, synchronize your clock in all of your controllers, and we hold the frequency of the transmitters to, at VHF, we have to be within 10 to 20 hertz. You can sometimes get away with up to 50 hertz difference. We actually transmit two signals at the same time. You have to put in identical modulation. And you can actually, you will not hear a heterodyne or a squeal. And you get the coverage, the best of both. So we're not doing this right away, but imagine if on Calcon Denver, we were to be transmitting from both Thornton Mountain and Squaw Mountain. And wherever you went, you're going to hear the stronger of the two transmitters because they're synchronized. I kind of use the analogy, it's like the Radio City Music Hall Rockettes, where they all kick together, and it looks really great when they're costumes and they're dancing and they got their legs kicking together. But if one rockette is off, it doesn't look so good. That's what we use the precision 10 megahertz reference. That will be a reference that is GPS synchronized, that the GPS signal, that PP1S that Steve asked about earlier, is actually used to train the 10 megahertz reference oscillator and give it additional stability. You could get away with a rubidium oscillator, but we're looking at a reference oscillator that's about 10 to the minus 12 or 10 to the minus 13 stability. that allows that when we put that into this repeater, we can get a precise frequency and modulation, and we also have to send the same signal to the RTCM, because this is doing the digital to the analog conversion. If I don't synchronize these modules at the two sites, the Rockettes are out of phase in their kick. So that's our goal, to maybe be able to do some frequency conservation. Or imagine if our Fort Collins, our Denver, and our Colorado Springs repeater on Colorado Connection were actually on the same frequency. And all you do is drive, and you automatically switch from receivers to receivers. And as you drive over one hill, you'll, instead of picking up the transmitter to your right, you pick up the transmitter to your left. There are some challenges. You are trying to very critically control physics in amplitude and phase and frequency. If a repeater fails or the transmitter drops by, if I have, in the example, I have transmitter on Thornton and Squaw, and one of the transmitters fails, how do I know? I'm just going to hear the other transmitter. It's just going to naturally fill in. So you need extra monitoring, extra sample, signals and test units to. We're not there yet, but that's our goal, to be able to go there. Is there a question mark or? Oh, okay. So we're now to the point of, are we there yet? We want to open up to some questions. You're probably getting tired. I'm getting tired of talking. So, a little bit blurry there. There we go. We're back. So why don't we open up, as they say on the radio, let's open up the phone lines, and feel free to unmute, put some video up. What are the questions, other than giving you a tour of some of this equipment with the close-up camera? Have I put everybody to sleep?
There was a comment earlier.
Doug, this is Will, N0XGA. Are all the connectors in the MPR 2000, are they all identical, or are they special purpose?
You're saying on the back plane, they have different functions on different rows of the connector here, but they're documented.
Okay.
So you'll want to get this installation and operation manual, Will. It's got a big long part number, and I got it off Repeater Builder. So it's a free download, and I think it's so old that Motorola doesn't care anymore. And if you have the stamina and you suffer through 35 pages, you'll get to what the connector signals are. In the back here. So.
Okay, thanks.
And for everybody on the call that you can see, that's Will, N0XGA. He's one of our CalCon board members and our CalCon treasurer. And also, I don't know if he formally took the position, but I consider him to be kind of the project manager, technical lead on this Voter 2000. He's done an awful lot of work. He builds incredible things. As you can see behind him there is his, is that the clock with the Nixie, or is that the regular clock behind you? But
no, that's the Unix time clock. That's pretty boring, but still nerdy.
okay. He builds really cool things. Do you have one of the Voter 2 prototypes there, Will?
I'm gonna get one here. Hold on.
Okay, I'm sure people would love to see that. Now, I don't think he really builds all this stuff in that workshop there, because it is way too clean. Yeah. Joe as Joe chimes in here, isn't that too clean? Maybe you
That's
just
only because he's retired.
There we go. There's the.
Okay. So
You can
there's
see
the
it. There's the
original-
Voter 2.
we were calling voter 2. What I told Will is, don't worry about the size. Just put it all on a board and let's figure out if it works. And so what he's doing is he took everything in the RTCM and then he added a few things that you'll see. There's a BNC connector on there that I think that's that white one, isn't it, Will? That's the reference input so that we could simulcast hopefully someday. And I'm betting, Will, that we can get the 10 megahertz signal for that. If we feed it into the MTR 2000, I'll bet you we can get that signal on the backplane connectors. I just haven't found that out yet. So, but he also added a CTCSS filter, or is adding a CTCSS filter to the circuit. Because one of the problems we have is anybody that's used the connection has heard us occasionally go into the offline mode. What that means is these RTCM modules that we were talking about require either, in the most basic of installations, a Raspberry Pi, but that will only really do one repeater and maybe 2 receivers. But in the case of Colorado Connection, we have multiple rack mount PC servers that are running our back-end repeater controlling. And so when that isn't available, this RTCM goes into what it's called a local mode or an offline mode, where it just loops the audio back around so that the repeater works as a local repeater. Problem is the CTCSS filters and the tones just ramp right through. There's no level adjust for the local audio. And it's very rudimentary, and Will is adding some circuitry to tame that beast a little bit. If not already in that board, we will be adding it. We've identified it as something that needs to be done. So we will very shortly, I will get one of these frames for Will and send it down to him, and we'll interface that controller of his through one of my nifty handy dandy cables here and start to experiment with that. And remember, I went through what Mark and I went through on the Kenwood and the other. We're going to start all over again and find, do we need a rubber mallet or is this thing going to cooperate? So,
Hey, Doug?
Yes.
We've got a few comments on the chat.
Okay.
There's Tristan says there's a voted and simulcast ham system in the Bay Area that is mostly built out of handmade or modified equipment, wb6ece.org. Yeah, I'm personally also aware of one in Chicago like that.
There are a few out there. I actually helped to build one in Lynchburg, Virginia when I lived there in 1995, and we were on 900 megahertz. Yeah, Tracy will like that one. And it was simulcast, but boy, it was a lot of work and it was not mass produced. But yes, there are some out there. You can do it, but you've got to, you really need to have local people around all the repeaters, because otherwise you're never going to know if one has gone out into the weeds. So I do it for commercial, and we put a lot of effort, a lot of synchronization, a lot of test units that we can measure everything on every repeater site. So
There's, let's see, Ed, WA7EM mentions there's one in Spokane, Washington as well.
yeah, there are a few.
Sort of, so there's a comment or a question from Dave K0IRP.
Okay.
But he mentions a Motorola MSR 2000. He was wondering if anybody makes any synthesized channel element replacements.
Don't know about that.
I'm not aware
Yeah.
of any either. I know there's been a lot of work done in that area. Some of these really new DDSs, especially made by Analog Devices
Yeah.
and others, there's too much phase noise.
Yeah.
When you multiply it by 12 to get it up into at least the 2-meter band.
And there probably is something out there, but I'm not aware of it. MSR 2000, MSF 5000, they were good repeaters in their day, but they're starting to become a little harder to find. And I just said, for us, we're not going with anything other than this. I'm not going anything older than a 2000. And my goal is to seamlessly move to 3000 and 5700 someday when we get the controllers that can support it. But there may be something out there, but it's too old for me. Is there anything else in the chat, or does anybody want to open up their mic and talk? It's okay to talk.
Yeah, Doug, this is Joe.
Joe.
Yes, I knew about your RTCM project. I'm just curious where you're actually at on the design and possibly being able to release something to everybody, because I know everybody's looking for these things.
Yeah. Well, you saw the board that Will had, the little purple board, and I anticipate in the next month or two we're gonna, assuming Will has time and I have time and I can keep family members out of the hospital so I get time, like I had happen last night. We're gonna work on that and then hopefully get a board run. I don't know if we'll be able to deploy Voter 2000 in summer 2023. I'd like to, but certainly mass deployments for repeater season 2024 with hopefully some initial. We would be probably looking for some groups with a little more accessible sites than Colorado Connection has. To get to Thornton Mountain these days is a snowcat. To get to Squaw Mountain is a snowcat. We do have a downtown Denver site that we're just putting online, and this would work very well down there because you take an elevator to the 43rd floor and it's accessible all year long. But if a group has a site, we'd love to have them as part of the beta, kind of the test program. And so help us get it out sooner. We all want it.
Thank you. I appreciate that.
So anybody else for some show and tell or?
Well, Doug, Sky Hill is a year-round site, so that'd be a really nice place for us to do some test bedding.
Yeah, and
Critchell too.
Dave says El Dorado, and so and I like the pictures of the dogs, Wayne. I guess that's Cody and not Charlie, Buddy. No, Charlie.
Charlie,
Yeah, there they are. So yes, one of the things we're doing is Aurora Repeater Association, ARA, is part of our effort, and we will probably do some of this on Guy Hill, and those of us at the Connection will be promoting our partner groups more and more, especially to, hey, go out, you want to have a local QSO, move to the ARA machine. And when you want to have a networked, a wide area, move over to Qualcomm. And we'll get these modules and these systems capable to link and get some airtime on them, and that's the best way to test them out. So we can do the same thing with CRA's El Dorado site, maybe on the UHF, since the VHF would put a pretty big, well, maybe they'll be compatible, I guess, to talk to each other. But, so we kind of said when John Thompson, W0IG, who used to be in the area, we all remember him from HRO, but he's now living in San Antonio. He said, we're going to do a technology merger between Calcon and Rocky Mountain Ham. We still exist as two separate 501c3s, but we help each other. We share a backbone, we share sites, we share costs of things to make it affordable. Share the tech teams a lot. And ARA is coming into this mix. CRA is kind of in this mix a little bit, although they use a little bit different hardware than we use, where ARA is going to exactly mimic what we're doing. And it's okay for a group like CRA to deviate. They have the technical talent. But some groups are just running short or say, we don't want to do all that engineering. So just, if you don't want to do that, implement what the common group has done. But if you want to deviate, go for it. But we can't help you fix it if it doesn't work. There's just too many permutations out there at that point. But and the same thing with the fun machines. We're starting to work more hand in hand with them down in southern Colorado. So yeah, we need to get some of these on the air. And Fun Machines also wants to be simulcast. They're attempting to simulcast, but it's still a little rough because they haven't synchronized their CTCSS tones. They haven't really synchronized their audio. So when you get into the overlap areas between the two sites, it sounds a little bit like Patty and Selma Bouvier on The Simpsons. It's got that gravelly voice and just doesn't sound clean. But hey, he's doing something, and that's cool that he's moving forward. So who else on here? What else do you want to see? We could do some close-ups of some of this stuff. Or maybe Mark, do you have the close-up cam there? And we can show a little bit of, unless people have some things, questions, or throw them in the chat, put them on. Just unmute yourself. And Mark is, okay. So can I zoom in and out? There we go. And there's Mark. There's Dave looking into the spotlights. So this is the back of the MTR 2000. And you can see there's one 96-pin connector back here that normally, if I didn't have this little security guard so that it can't fall out on, I would just plug this board right in here. And that's how we're getting the interface for the RTCM. This unit has not been modified. It's still a simplex or a half duplex unit. It came out of a city, county sheriff, city police, county sheriff's site. So they were running a common antenna with receive and transmit switching. We'll just take this out and put a connector on the back. The DC input for either 12 or 24 volts, depending on what it is. Your transmitter output on the side here, either 40 watts or 100 watts, depending on how big a unit it is. The AC power is over here. Nice ground lug that you can do R56 grounding, which is kind of nice. The little cover here just snaps on, and if it weren't sitting on a table, you pop it off, and there's your power supply. This one is a 40 watt unit, so it's a 12 volt or 14 volt power supply here with 12 volt battery input. Power amplifier over here. And there's the view into the card cage. So you can see the line card, the empty slots, some connectors for microphone programming if you need a speaker. There is no speaker indigenous to this, so you plug one in when you need one. You hardly need it. And if you need one, they make this little external filter for receiver, and you can add some receiver filtering. This one happens to be a UHF, the other unit's a VHF. And this is actually an MTR 3000, but I brought it for show and tell. That's the platform, and so we usually, for RTCM, we just glue it with some double-sided tape up there. This little cable comes around to the back, plug in Ethernet, GPS, and go. I guess I got it backwards here. It goes like that. So you can see the switches and the thing. So I'm going to switch you back. But that's the new platform. The old had a power supply, then it had a repeater, and then it has some controller pieces. So we've condensed from something this big down to something this big. So anything else in the chat or in the live audio?
Yeah, when we're all done, I was going to let Wayne, is going to have a couple words for us. And I know Willem had some time getting home, so we'll give them a chance here
Okay.
at the end if we don't have any more on your presentation.
So hopefully this was of interest to people. I've been getting requests for, you disappear on these mountains and you do all this stuff and I want to know a little bit more. Well, you know a little bit more. If this is of interest, let us know. We need more people to help. The whole idea of doing this standardized platform is it's going to be easier to work on. I can send you spare parts. I don't have to travel to Durango or Grand Junction or even Fort Collins on a regular basis. We're going to have documentation. We're going to be moving this material forward. And it should be good. So any other final comments, questions? I guess, Wayne, did you want to present something you said, or was Willem made it online? The professor in the house?
I had couple things I wanted to bring up concerning our Rocky Mountain Ham U. Doug, can you hold up that little fancy thing in your hand there, that clicker, your little clicker?
This thing?
No, the clicker for the presentation,
You don't want the liquid death. You want this.
not the liquid. Okay, if everybody was impressed by what that does, that's some of the stuff that Rocky Mountain Ham Radio is spending more and more money on, is acquiring things to make our presentations better. And I think everybody probably appreciated the way that clicker worked and the way Doug could highlight the things going on. So we want to remind people, we also are looking at getting another camera, one that's superior to what we have, and so that we're not using our phones as much. So I'd like to encourage you, if you haven't already lately, rmham.org. There's you go right to the front page. There's a bunch of ways that you can send us a couple of bucks, help cover the cost of something like the little clicker. The little clicker, by the way, was $100 that he has in his hand. So just a shameless little plug.
So, and
And we
Wayne,
appreciate
how
it.
did you
We're
know
always-
that I wanted one of these little clickers? I sent this to Mark and said, we need one of these. And so whoever got it over to you, thank you. Because yes, this is very useful as opposed to saying, well, those of you in the room can see the red dot on the screen, but everybody online has no idea what we're pointing to. So, yes.
And that was purchased by Rocky Mountain Ham Radio and was delivered just in the nick of time for your presentation today. So if you can give us a hand with a couple of bucks, people, please go out and to the website, rmham.org. And thanks for the time, appreciate it.
And Wayne, thank you for doing this. And I don't think he's on the call, but James Isaac often, when he's at a RMHAM or an NCARC meeting, he goes, we are not a bank. Let us not just build a big bank account. Let's use our stuff to its benefit. And I'll put in a shameless plug for Colorado Connection. We are doing that fundraiser right now. We've been able to obtain these MTR 2000 repeaters. partially with a corporate match, but also with member donations. And Will has mentioned it. Mike Randall's on the call here has mentioned on the air. You know, we're trying to upgrade to all this similar things. And I guess it's not widely known, but it's not a huge secret. The corporate match is coming from my company, Triple C Communications. I was able to obtain these repeaters, and so we're going to donate them from Triple C to the connection, but that won't get us to the finish line. We need other things. We need batteries. We need GPS modules. We need controllers, and that's what
Solar
the match-
panels.
Solar panels, there you go. All of these things we need to make a full deployment. And so I'll help with the lifting on the repeaters because I was able to get these on a trade-in. And I think the best possible future for them is in ham radio. But But we need your help to do the rest of the lifting, and I know the donations are starting to come in. I promise we will use it wisely, and you will see how it's being used, like in these talks. Probably going forward, and I don't know, I guess we're a little over on time, so we should wrap up. We'll probably do another session that's an even deeper dive on this repeater. I may do one where we actually live deploy and configure and align one. So anyone is welcome to do that, but it'll probably be a smaller group. We will try to do also the back-end server talk. I've already voluntold Mark and Dave and also Willem. If he's not online, he's gonna,
as well.
and James, we're gonna try to do one of these on the All-Star dial servers that connect all of these repeaters together. So we're going to try to do some more. We're going to have team meetings on the Voter 2000. So if you're interested in that, let us know and you can be part of the team. This is not an exclusive club. We need more people to help. I'm glad you were here. I hope you had a great holiday for Christmas, Hanukkah, Kwanzaa, Festivus. And I hope everyone has a great new year and happy and healthy in 2023. And unless anybody has anything else.
Doug, Joe again.
For us?
Joe, and then we'll throw it over to Willem.
You said that James says we're not a bank. Are you sure he really said that?
Has he been spending your money?
Oh, well, I've been sending a lot of it now, but in the past, he's very good. And by the way, if you need a repeater spot for putting one of these things, NCART will be backing you 100%. Well, you can go to any site we've got.
Yeah, I'm thinking we might want to, I'm sure James is going to want to adopt this platform for NCARC. And as an NCARC, I'm also an NCARC, oops, I'm banging on my microphone. Sorry about that. I'm also an NCARC member, so I want to see this work benefiting all of us. And NCARC has also already started going to this repeater platform, and I think it's just a natural because we can support each other. So, yeah.
I was quite excited when I was quite excited when he showed me this, and I said, "Hey, let's just do it." You know, I mean, we've been having trouble getting parts for everything else, and let's just do something standard.
Yeah. So, and another shameless plug, Joe, maybe I should bring this to a particular ham fest in January and show and tell. Could you tell us about that so that those on the call here could attend?
Oh, sure. I'm always looking for sell something. When is it? It is January 21st. It's a Saturday, Hamfest at our place here at the well, not the Budweiser Event Center, but the ranch. We will be at the Thomas McKee building. As everybody knows, it's one of the biggest ones. We have 400, 500, even 600 people show up to this one. Got about 40 tables for sale. You better get them because I think they're going to go pretty quick. Rocky Mountain Ham will be there with all their stuff, and I thank everybody for coming.
Yep. RMHAM will be there, but RMHAM will be there working with our partners at NCARC, Qualcomm. We're not going to be there to represent the one group. We're going to represent all of us. So please come. Then in February, Wayne, February, is it 21st?
February 19th.
February
The Adams County
19th will be the
Fairgrounds.
Swap Fest at the Adams County Fairgrounds. And so there's another Ham Fest, and RMHAM and the groups will have a big presence. And okay, 2 commercials. Willem, did you have something you wanted to close with?
Just wanted to say, first of all, thank you very much for putting this on, Doug. Very much appreciate you taking the time, putting this all together. Sorry I missed the first part of your call. It took me 4 hours to get here from Greeley, so it was a fun drive, and past many power company trucks on the way. I just wanted to remind folks that our next RMHAM University is January 14th. And it was going to be the 3D printing, but we had to move that. So the 3D printing, RMHAM University, will now be on March the 18th. And instead, on January the 14th, John Maxwell and I will talk about all the kinds of problems that you can solve when you have IP available, the Internet Protocol available. So that change in schedule is something that just happened in the last week or so. So if you have already signed up, you would have been transferred, but just bear in mind that the calendar has changed. Happy New Year to everybody, and we hope to see you soon.
Yes, and Happy New Year to you. And by the way, Willem, I think you get the award for the best background wallpaper of anybody.
And it's not wallpaper.
I was going to say, everybody watching today, that's real. And I love the Heathkits in the background. That is so cool. So,
Those are Jesus.
are those Jesus?
Yes,
They look
they're
green.
mostly.
They don't look gray from here.
No, the light's bad. It's those are mostly FT 101s or FR 101 pairs.
Okay. Well, when I was growing up as a young ham, I had Drake, but yeah, from this angle they look a little green. But okay, Yesu. Excuse me.
Yeah,
Happy New Year, all. Does anybody else have anything before we shut this down?
This is
Okay.
Dave. Thank you
Yeah.
very much, Doug.
Dave, and for everybody, Dave is president and board member in the Colorado Connection, so one of my partners in crime in this project. So glad you could make it, Dave. There were so many on here.
Thank
Dave,
you.
Dave Mack, do you know how many were actually on here?
It went up to 40.
Went up to
41.
Wow. You guys really got
Great
to
job,
life.
Doug. Thanks a million.
If you're sitting here listening to me, you got to get a life. Great to see everybody. Thanks. Happy New Year.
Hey, our thoughts and prayers for your dad.
Thank you. He is doing better. So for
That's
those that
glad.
didn't hear the story, I had to take him to the emergency room last night, but he's doing better.
Good.
He threw me out of the hospital and said, "Go do your session." So
That's
Well,
what dads
thanks.
do best.
Give him our best.
thank you, guys.
Thank you, Doug.
Happy New Year.
Thanks,
all.
Doug. Happy New Year. Happy New Year.